Hello students, in this video, we're going to do a quick revision on how to solve problem sums involving quadratic inequalities. Do get ready a pen and some papers and practice along with me. Right, so how do we form quadratic inequalities? It can be formed where we have a curve intersecting a line, or rather a line intersecting a curve. It could be intersecting it at 2 distinct points. In this case here, then we will say that it has two real distinct roots, or it can intersect at only one point, so two real and equal roots, or sometimes they call it two real and repeated roots. Sometimes if you say that the curve at the line has two real roots, it means that it could intersect at 1 point or 2 points. That means it's actually a summary of your first and the second case. Put them together and that become two real roots. Or the curve does not intersect the line at all, then of course there's no intersection point, so that it means there's no real roots. So what determine whether it has real distinct, whether it has two real distinct roots or two real equal, or two real roots or no real roots? It's this thing called the discriminant. And what is this discriminant? So discriminant is this thing called b squared minus 4ac, where you can actually find it in the quadratic formula. Remember, the quadratic formula is used to solve an equation, is to find the values of x. The values of x of an equation, which is the solutions, which is also the roots of your equations. So it's this value here that's called the discriminant. So this is a very important value, because this value will then determine what sort of roots you have. Okay, if the values is more than 0, then you would have two real and distinct roots. Equal to 0, two real and equal roots. More than equal than 0 is two real roots. But less than 0 means no real roots. Right, so how does it look like graphically? All right, so what is A? A is the coefficients of x squared. So that will determine the shape of the curve. If your A is a positive value, like for example, like 2x squared plus 4x minus 6, then you would get a U-shaped curve. Right, so this is what I explained earlier on about two intersection point, one intersection point, so on and so forth. If the values of your A is less than 0, then we are referring to having a N-shaped curve. All right, so this is the concepts that needed, okay, to work on problems involving quadratic inequalities. Right, so let's look at the first question. So for this first question, we asked to find the values of the constant k for which the curve, this particular curve, lies entirely above the line y equals to x. Right, so if you look at this curve here, we can see that it's a U-shaped curve because the coefficients of x squared is 1x squared. So here we are saying that a is equals to 1, which is more than 0. So it means that we'll get a U-shaped curve. And then this curve lies above the line y equals to x. So if you have a line y equals to x, and you want to find the values of k such that this particular curve, something like that, okay, lies above the x. So when you say lies above, entirely above the line y equals to x, it means there is no intersection point at all, right? So no intersection point. If you were to recall the earlier slide, it means no real roots. And so the no real roots or two real and distinct roots, that kind of thing, is determined by the value for b squared minus 4ac. Okay, right. So this is what it's all about. So what we need to do is we need to generate an equation in terms of x only. And then we're going to find the let the value of your discriminant. let it to be less than 0. Right, because in the earlier slide, right, we explained that if the value of your b squared minus 4ac is less than 0, it means that your quadratic equation has no real roots. Okay, so I have two equations here. I'm going to call this equation 1. I have y equals to x, call this equation 2. I'm going to let 1 equals to 2 so that I can generate a equations in terms of x only. All right. Right, I need to simplify further because you see that I have two terms involving the common factor x. So I need to factorize the common factor out. All right, and then simplify further. All right, so I'm going to compare it with the general form for my quadratic equation. So the coefficients of x squared is a. So in this case here, a is equals to 1. B is the coefficients of x. In this case here is 2. And c is equals to 1. All right. So our situation is such that, okay, I should not draw a line because I can't draw a straight line. Okay, let me try again, see whether I can draw. Okay, sorry, that's the best I can draw. Let's try again. Okay, so we have agreed that because the curve is entirely above the line y equals to x, means there's no intersection point, no real roots. It means that the value for b squared minus 4ac strictly less than 0. So I would have b as 2k, a is 1, c is 1. So I would have 4k squared minus 4 less than 0. I can divide by 4 to get k squared minus 1 less than 0. Now, when you solve quadratic inequality, you have to be careful. It's not the same as solving a quadratic equation. In this case here, you would have to factorize it. And we will have to draw your quadratic curve to determine the region. Right, so when you let the x-axis is when you let this inequality equal to 0. So your k can be -1 or 1, right? But this is a quadratic inequality. So the region that you are interested in is this region here, which is less than 0. So less than 0 refer to this part of your curve. And the x value for this part of the curve will come from this line here, which is anywhere between -1 and 1. So in other words, your k can be anything that's more than -1, less than 1. And if the values of the k is anything more than -1, less than 1, that will give you this situation where the curve lies entirely above the line y equals to x. Right, let's look at the next question. The next question involved a curve given to be y equals to 2x squared minus 6x plus 3. So there are three parts to this question. Part A, you are told that find the set of values of x for which the curve lies above the line y equals to 11. Right, so this is not so similar to what we have done earlier on, although the concept is still the same. Not so similar, meaning you will see that there's no constant in your quadratic curve. Right, so that there is actually no you can't generate equations in terms of x only because it's same but different. What I mean by same means your curve is entirely above the line y equals to 11. So it means that your 2x squared, the y values for your 2x squared, right, minus 6x plus 3 are more than 11. See the diagram I've drawn for you. Okay, the y values for all values of x, right, it's more than 11. Right, so this will form a quadratic inequality. Where we can factorize it. Right, and then same meaning to solve the quadratic inequality, we will have to draw your quadratic curve, and it's a U-shaped curve because the coefficients of x squared is 1. So it could be, if you let the quadratic inequality, let it be an equation on the x-axis, that means your x-intercept, the x-intercepts can be, if you let this guy equal to 0, x-intercept can be -1 or 4, right? Okay, so the region that we are interested in will be more than 0, will be this part of your curve. And the corresponding x value will come from this line here, right? Which is anywhere that's less than -1. The other region is this, right? So therefore, the answer will be x less than -1 or x more than 4. And we asked to represent it on the number line, right? So you have to draw a number line. Basically, you can just have 2 points will do. Let me draw it properly. Just the 2 point there, -1, not point, sorry, 2 value, -1 and 4. So x is less than -1. So it's the empty circle, goes to the left, more than 4 go to the right. Okay, so this is how you do part A. All right, so let's see how we can do part B. So for part B, we are told that the line y equals to 2x plus k is the tangent to the curve at point P. All right, so we have this one is a quadratic curve. All right, so quadratic curve is a U-shaped curve. So let's have a U-shaped curve. And you have a line y equals 2x plus k. So it's a positive gradient. So tangent means you cut the curve at only one point. So that is the important concept here. When the line is a tangent to the curve, means it cuts the curve only at one point. So that point is called point P. Right, so find the values of constant k. So in this case, can you see that you do have an unknown here? So I can generate equations in terms of x to find this unknown k. So it's quite similar to the questions we've done earlier on. So let's generate the equations in terms of x. Right, so if you compare with your quadratic general form for quadratic equation, so clearly a is equals to 2, b is -8, c is 3 minus k. All right, so here there's only one intersection point. So if you were to remember the first slide, the second slide that we have gone through all the concepts. If there's only one intersection point, then it's 2 real and repeated roots, or 2 real and equal roots. That is when the value for discriminants is equal to 0. So that will be, make sure you bracket it. That will give you 64 minus 4 times 2, 8. 8 times 3, 24. Negative times negative, positive 8k. 8k equals to 64 minus 24 is, how much is it? 40, right? So -40. So k is -5. All right, so that's how you do part B. All right, let's go on to do part C. So for part C, ask to find the coordinates of P. All right, so we already found K to be 5. So in other words, to find the coordinates of P, you just have to solve these two equations simultaneously, right? So 2x squared minus 6x plus 3 is equals to our 2x plus k. But k is negative 5, so it's 2x minus 5. Right, so we will end up having a quadratic equation divide by 2, and we can factorize it. We'll have x equals to 2. It's a repeated root. Yes, it makes sense because there's only one intersection point, so it's 2 real and repeated, or 2 real and equal roots. Right, so when x is equals to 2, you just have to substitute into your, of course, it's easier to substitute into y equals to your equations of the tangent line, y equals to 2x minus 5. All right, you won't want to substitute into your quadratic curve because there are more terms to calculate. Right, so you have y equals to 2 times 2 minus 5, that gives you negative 1. So therefore, your point P will just be 2 bracket negative 1. So this is how you do part C. Right, let's look at the last questions. The last questions involved a curve y equals to 9x squared plus bracket 2x plus 1 close bracket x plus 1 plus c. M and c are constants. So you have a line y equals to mx plus c is a tangent to the curve at point P. Right. So graphically, this is how it looks like. This is a U-shaped curve because the coefficients of x squared is 9. And then you have a line here like that. So it touch at only one point. So one intersection point. So the value for your discriminant will be equals to 0. Okay, this is what it means. Find the positive value of m. Okay, so we can do the first part. Let's generate equations in terms of x only. Let's bring all the terms to the left hand side. Right, you'll see that I have a term involving x, also another term involving x. So I'm going to factorize your x out. C and C will be gone, so left only 1. So I would end up having m plus 1. Or the coefficients of x. So if you compare it with your ax squared plus bx plus c equals to 0, a is equals to 9. Your b is m plus 1. Your c is 1. So using b squared minus 4ac equals to 0, you would use quadratic inequality to expand it, get m squared plus 2m plus 1 minus 36 equals to 0. You will get m squared plus 2m minus 35 equals to 0. Can factorize it. You will have m plus 7, m minus 5. All right, if you were to go back to the question, you asked for find positive value of m, so we need to reject this value since m has to be positive. So therefore, m is equals to 5. So this is first part A of the questions. So for part 2, using this value of m, which is m equals to 5, and we have a curve passes through this point. Remember, this point is on the curve only, on the curve only. Okay, right, we are asked to find the values of p, the coordinates of p, sorry, the coordinates of p. So p is here. So the coordinates of p means we need to find the x coordinate and the y coordinate. All right, so what we can do is we can substitute the point we can substitute the point, this point, since the point lies on the curve, and m equals to 5 into this, into here, to find the unknown c. Right, so we have 19 equals to 9 bracket negative 2 squared plus bracket 2 times 5, 11, x is negative 2 plus 1 plus c. Right, so if you were to work it out, 19 is equals to, you will have 15 plus c, so that gives us c equals to 4. Okay, so when c is equals to 4, we can make how should we do it? I still need to know my x coordinate. All right, so I'm going to use this part here. Okay, you don't need to solve the two equations again to generate the equation in x. We have already found it in star. Okay, we already found in star here. So we can just simply substitute m equals to 5 into star to get 9x squared plus 6x plus 1 equals to 0. So we can factorize it. So that gives you x equals to negative 1/3. Okay, but we're still not done yet. Why? Because I still need to find the y coordinate, right? So this is where my tangent comes in. Because the point P, remember x equals to negative 1/3 is the x coordinate point P, and point P lies on your tangent line also. Right, so we're going to substitute x equals to negative 1/3, c equals to 4 into y equals to your mx plus c. So you will have y equals to 5 times negative 1/3 plus 4, and that gives you 2 and 1/3. So therefore your point P will be negative 1/3, comma 2 and 1/3. So that is part 2 of the questions. Okay, so for part 3, you're told that given L is not a tangent to the curve. Okay, so now they're telling us that it's not a tangent to the curve. If it's not a tangent to the curve, what can you deduce about L? Right, so if it's not the tangent to the curve, then what sorts of line will intersect the curve at only one point? How would this line, okay, so we can try to use a few. Right, so we can look at how your, oh my God, I think it's hang already. Right, so for the last part of the questions, we are asked that if this line here, y equals to, we found out m to be 5, right, and c to be 4. If this line is not a tangent line, then how do you think this line can be such that it will intersect the curve at point P, right? So can it be like that? If it's like that, then it is a tangent line. Because basically tangent line means it intersects the curve at one point. You draw this way is also a tangent line, right? So how can you draw it such that it's not a tangent line? Yeah, you can only draw it vertically. Okay, so therefore L is a vertical line. Okay, this is what it means. Because if we draw it this way, this one becomes a tangent line. Draw it like that, also tangent line. Draw like that, it's also tangent line. Right, so the only way you can draw it, it's a vertical line. You can't draw this way because it only intersect the curve at one point. So this is out also, out, out, out. Okay, right, so this is how we do it. So happy learning.